let's go to page 293 and start with number 1. So again, when you have the word problem, read through first to get an idea what kind of problem you have. Okay, so sometimes you might have to read over several times. So this is the motion problem, so let's go and draw pictures. Okay, so you have, so this motion, so you start from, so they start from San Diego and they're going to San Francisco, and they left at 7 a.m. Let's see, let's go and write it here. Okay, 7 a.m. and bound to, okay, their neighbor, so this is the Malone family, and then you have another family over here. Their neighbor King's family is left at 8 a.m. Okay. Okay, by traveling 9 miles per faster, so this one R equal to X, because you don't know, so you set it equal to X, and this one the R is 9 miles, so this is a 9 miles per hour faster will be X plus 9, okay? And they traveled, so they overtook at 1 p.m. So they didn't quite make it yet, but they reached it by 1 p.m. Okay? So by doing this, you can see the time from 7 a.m. to 1 p.m. Okay? It's going to be 6 hours. And 8 a.m. to 1 p.m. is 5 hours. Okay? Okay, so let's go and make the table for the motion problem. So it's R times time equal to distance. And let's go and do this. So this is the Malone family. So this is the Malone family and the King family. Okay. Okay. So for the Malone family, the speed is X, the time is 6 hours, and distance you don't know, so you just multiply with 6X. Okay, for the King's family, the rate is X plus 9, and the time is 5. So when you multiply, you get 5X plus 45. Okay. Now so this is the distance for each family. Then if you look at the picture, since they start together and at the same place, right, neighbors, right, and they overtook means the same thing. So that means that distance are equal. Okay. So your equation would be 6x, the distance by the Malone family, will equal to the distance by the King family. Okay, and to solve, you just minus 5x on both sides. So you get x equal to 45. Okay. Now, you make sure, don't just box that. You have to go back and answer the question. Okay. So A, what was the average speed of each car? So speed is this over here. So for the Malone family, x would be 45 miles per hour. For the King family, is x plus 9. So it'll be 54 miles per hour, right? You can see the rate is a speed. So speed for the King family is x plus 9. So 45 plus 9 will give you 54, okay? Then for the B, what's the total distance by each car before they met, okay? So the distance is this over here, so so you can use either one. So the distance will equal to 6 times 45, okay? So you get your calculator. So let's go, okay. So 6 times x, so 45, equal 270. So it'd be 270 miles. Okay. Okay, let's go to the next one. Again, read through. So Trent hiked from his camp to a lake and a mountain and returned to camp later in the day. Okay, so you're hiking. Okay, so here's the camp. and here's the lake. Okay. So he walked at a rate of 2 miles per hour. So when it's going, the R equal to 2 miles per hour, and coming back, the rate equal to 5 miles per hour coming back. If the trip took 3 hours longer than the trip coming back, okay, so to the lake is 3 hours longer than that. So this time will equal to x, and this time will equal to 3 hours longer to be x plus 3. Okay, so get all the information together. Okay, so let's go and make the table. Okay, so this is going, so this is 2, and this is return. Okay, going to the lake, the rate is 2, the time is x plus 3. Return, the rate is 5, and the time is x. So you multiply, okay, to get a distance. So this is 2x plus 6, this would be 5x. Now since it's going to the lake and coming back on the same route, that means that distance going and coming back will be the same. So your equation will be 2x plus 6 equal to 5x. Okay. So minus 2x on both sides. So you got 6 equal to 3x divided by 3 divided by 3. So you got x equal to 2. Okay, once you find x equal to 2, you have to go back and read the problem to answer the question. Okay, so A, how long did it take to hike to the lake? So you're looking for the time to the lake, so it would be x plus 3. So A would be 5 hours. Okay, so again, the time to the lake is x plus 3. So x plus 3, 2 plus 3 give you 5. Okay, then you go to B. How far is it from the camp to the lake? So the distance is camp to the lake. Now it's easy if you do this one, because the camp to the lake is same as lake to the camp, right? So easy if you use this one. Okay, so the distance will equal to 5 times 2 will equal to 10 miles. Okay, if you use this one, it's the same thing. 2 times 2 is 4 plus 6 give you 10. Okay, so again, once you find x, you can look at the table and you can find the answers you're looking for. Okay. Okay. Let's go to the next one. Okay, number 5. Again, read through the problem. So this is the motion. So let's go and draw the picture. So it says Anita and Felix live 54 miles apart. So here's your Anita, and here's the Felix, and they are 54 miles apart. Okay, again, draw a picture and help you to visualize. And both leave their home at 7 a.m. by bicycle. So 7 a.m. and 7 a.m. Okay, and they're going to go toward each other. Okay, and so they're going toward each other, and they're going to meet right somewhere in between. Okay, so the Felix average speed is 2 miles faster than Anita's. So the speed over here, that's called the x, and this one the speed would be is faster, so it'd be so faster by 2, so it'd be x plus 2. Okay, and they met at 10 a.m. Okay, so that means the time is equal to 3 hours for Anita, and the time for the Felix is also 3 hours, right? Because they both start at 7 and they meet at 10, so both spend 3 hours. Okay, so let's go and make the table. So R times time equal to distance. This is Anita and this is Felix. Okay, so the rate, R is the speed, so be x, and the time is 3 hours. The distance would be 3x, right? It's R times time equal to distance. You multiply it down. And for Felix, the speed is x plus 2. The time is 3. So multiply, you get 3x plus 6. Okay? But looking at this tape, look at this picture over here. This is the distance of Anita, and this is the distance by Felix. Notice the both of them together, the two distances together equal to 54. So that means that the distance of Anita plus the distance of Felix equal to total of 54. Okay? So again, you have to look at the picture to see if they're equal, or you have to add equal to the total. So combine our like terms, so you're going to get 6x plus 6 equal to 54, minus 6 on both sides. You got 6x equal to 48 divided by 6. So you got x equal to 8. Okay. Then you have to answer the question. Okay. It's how fast does each cycled. Okay. So you're looking for the rate. So for Anita, its x would be 8 miles per hour. For Felix, it's x plus 2, so it would be 10 miles per hour. Okay. Okay, let's go to the next one. Okay, I can read through. So kayak downstream for 3 hours after having lunch, going back upstream. Okay, so canoe. Okay, so it's going, or kayak. Okay, going downstream for 3 hours. Okay, so T equal to 3 hours. And after lunch, took 5 hours to paddle back upstream. Okay, if the speed of the stream is 2 hours, so the stream, the water, is going at 2 miles per hour. Now I put in between because it doesn't matter if you're going down or going up, the water is still going downstream, right? And how fast does Abdul row in the still water? So you're looking for stream. Okay, so again, this is the motion problem. So this is R times time equal to distance. This is downstream, and this is upstream. Okay, so when you're going downstream, it would be the speed would be the kayak plus the water. Okay, so again, kayak is going down. So this is R, and okay, so R will equal to the kayak plus 2. Okay, and the time is 3 hours, so this would be 3K plus 6. Now when the kayak is going upstream, so kayak is going up, but the water is pushing it down, so it'd be minus 2. Again, when you're going upstream, the water is pushing it back, so that's why you have the minus 2. And the time is 5 hours. Okay, so this would be 5K minus 10. So when you're going down and going up to the same place, so the distance will be equal. Okay, so you got 3K plus 6 equal to 5K minus 10. So let's go and solve the equation. So minus 3K on both sides. So you got 6 equal to 2K minus 10. So plus 10 on both sides. So you got 16 equal to 2K. Divide by 2, so K equal to 8. Okay. Now, once you find K equal to 8, then let's go and answer the question. So first one, how fast does Abdul row in the still water? Okay, so that's that. So A, the answer A would be 8 miles per hour. Okay. For B, how far downstream did he travel? So how far? So the distance. So downstream distance equal to 3K plus 6. So K equal to 8. So 3 times 8 is 24 plus 6 is 30. So answer would be 30 miles. Okay. Okay. So you can. So this is what you're looking for over here. Okay. And that's it. Okay. Okay. Let's go to next one. Okay, number 9. Okay, so this is an airplane and it's headwind and back home. Okay, so it's going and the wind is going this way. Okay, and it's coming back. Okay. Okay, so when it's going, the wind equal to 20 miles per hour. Okay, and it says the round trip took 10 hours of flying time. So the total time equal to 10 hours. Okay, again, this one you have to read carefully and get all the information. The round trip took 10 hours of flying time. If the airplane makes if the plane makes 100 miles per hour in a still, so the rate equal to 100 miles per hour. So the airplane, okay. So airplane equal to 100 miles per hour. Okay, how far is the storage? So you're looking for the distance. Okay, so again, let's go and get our information together. Okay, so this is go and this is return. Okay, the rate of going, notice that the airplane is flying at 100, but I get headwind of 20, so you're going to net of 80, right? Because you're going at 100 and the wind's blowing back at 20, so you get 80, okay? And time, you don't know, okay? So let's go and call that x, okay? And so this would be 80x, okay? Now the return coming back, the airplane is going at 100 and the wind is blowing at 20, so it would be 120, okay, for returning. And the time, you don't know, again, doesn't tell you. And you have to use different variable because if you put x means they are the same amount of time, which is not correct, right? So this is the time it's going, okay, the time for going. This is the time for coming back, and it's equal to a total of 10 hours. 10 hours for the trip, right? Okay. So now, because there are two variables, you need to get two equations, okay? So the first equation is x plus y equal to 10. This is the time going, time coming back, and the total trip is 10 hours. The other equation is based on the distance, okay? So this is the distance going, this is the distance coming back, and since they're going the same route, so the distance going will equal the distance coming back, okay? Okay, so now, let's go ahead and solve for the x, and so we can substitute. So divide by 80 on both sides. Okay, so you got x equal to 1.5y. Okay, so let's go and substitute into here. So 1.5y plus y equal to 10. So when you add, you get 2.5y equal to 10. Divide by 2.5, divide by 2.5, so y equal to 4, okay? Now, once you find y equal to 4, you can find x, right? So x equal to 1.5 times 4, so x equal to 6, okay? Now, let's go back and answer the question, okay? What are they asking? It says, how far is the distance? Oh, okay, they're looking for the distance. Okay, well, the distance it's this one here, right? So the distance equal to 80 times x. So it'd be 80 times 6. So distance equal to 480 miles. Okay. Okay, and that's it.